Hello, shiny, happy people holding hands. Okay, so today is graphing polynomial functions. This is lesson 9. This is really just a combination of lesson 7 and 8 together, okay? So in lesson 7, we talked about characteristics of polynomials. We talked about how to know whether it opens up or down, how many x-intercepts we have, how many turning points we have, whether it, the end behavior, I know I just said opens up and down, but with the end behavior, I'm also thinking about like, did it behave sort of like a line or did it behave sort of like a parabola? Were my end lines both going up, or was one going down and one going up like that? Or all of those things we talked about in lesson 7. Then in lesson 8, we switched to really working on factoring and how to factor a polynomial that is higher than degree 2. So we find your first factor using the remainder and factor theorems. Once you plug that number in and you get out a 0, you know you found a factor. And so then you take that factor that you just found, you synthetically divide or long divide it out of the polynomial, you get what's left, and then you keep working on the leftover bit. Okay, so now what we're going to do today is put those two things together. You're going to draw pictures of graphs that have to be factored first, essentially, okay? So there's nothing really like super new in this lesson. It's just a combination of the things that we've already dealt with, okay? So this is not in your book, but just as a quick review, given this polynomial, I've got y equals negative 2, x plus 1 squared, x minus 2, and x minus 3 squared. Determine the following. What is the end behavior? Well, you're going to tell me right away that it ends down. The reason you know it ends down is because the a value there is negative. Determine the x-intercepts and the behavior of the graph at these points. So I have an x-intercept right here at -1. That is going to have a point of tangency, or you can say it changes direction on the x-axis. We have one at x equals 2, so 2, 0. That one will go straight through. And then we've got one at x equals 3 or 3, 0, and that also will have a point of tangency. So that also will change direction on the x-axis, okay? So I said it touches the x-axis there. Okay, determine the y-intercept. If I want the y-intercept, anytime I want a y-intercept, I plug 0 in for x. So I'm plugging 0 in here, 0 in here, and 0 in here. I'll get -2 times 1 squared, which is 1, times -2 times 9, because -3 squared is positive 9. So I multiply all that together and I get 36. So my y-intercept will be 0, 36. Now, without technology, sketch the graph. We're just going to put these pieces together, okay? So I know it ends down. I know I have a degree 5, which means I'm an odd degree. So if I end down, I also have to come in coming down, right? They're going to go in opposite directions if it's an odd degree, because it'll behave sort of like a line. So let's just plot all these things that I know. Okay, so here's a graph. I know I'm going to end down. I know I have to hit the x-axis at -1, at 2, and at 3, so I'll plot those guys. I know I hit the y-axis up at 0, 36. Now, just think this through. There's really only one general shape that you can make at this point, okay? I know I have to end down. I know I have to come in going down. I know I touch at -1, so at -1, I'm going to touch and change direction, okay? I know I have to hit that y-axis at some point. I know I'm going to have to turn around and come back through. At 2, 0, I go straight through. And then at 3, 0, I'll touch. So it'll go like that. So I don't know if you were actually following my mouse when I did that, but this is essentially what it would look like. Okay. Now, what you can't tell me based on this information is you can't tell me exactly where these maximum and minimum points are. Okay, they could be a little higher. They could have been, that maximum point actually could have been on the other side of the y-intercept. Like maybe it went like this, and then changed direction and came down like that. Okay, you can't tell me any of that stuff based on the graph, and that's, or based on what you know right now. When we get into calculus, you can, but for now, you can't, and that's totally okay. Okay, what we're looking for is the general shape. We're looking that you hit those points, and that you're accurate with those points and where you know you have to change direction, okay? Exactly how high it goes or exactly where on either side of the y-intercept it comes, that's not something to be stressed about, okay? Math's not supposed to be stressful anyway. Math's supposed to be fun. Math's supposed to be relaxing, so relax. Okay, good. Now, let's go through, now I am in your book, and we're just gonna go through all of these things and just try and get the characteristics that we can, and then try and get a sketch of it, okay? So essentially, we're just gonna fill in the missing pieces together. So in the first question, you were given this equation. The degree, well, remember that we talked in lesson 7, the degree of the polynomial is the sum of the multiplicities if I'm not in general form. If I'm in general form, the degree of the polynomial is the highest exponent you see, and that, if it's written in the proper order, would be right at the front, okay? But when it's written in factored form, you have to think through the fact that, okay, if I was to get this into general form again, I have an x times an x times an x squared. So my front term there is going to be an x to the 4. Okay, so this is a degree 4. Now, 2 seconds ago I said you could also just add the sum of the multiplicity. So you can look at this and say this has a multiplicity of 2, this has a multiplicity of 1, this has a multiplicity of 1. So 2 plus 1 plus 1 is 4. Okay, so it's a degree 4. The leading coefficient is negative, which means this graph is going to go down. I have zeros at 3, at -7, and at -1. At 3, I would go straight through. At -7, I would go straight through based on my multiplicities. And at -1, I would have a point of tangency, or I would touch. I would change direction at the x-axis. And then the y-intercept, I'm plugging 0 in for x. So I get -3 times -3. So I'm at 9 right now, times 7. So I'm at 63, times 1 squared. I'd be at 0,63. Okay. So then the sketch of the graph should look something like this. At -3, I went, at -7, I went through once. At -1, I changed direction. And then at at 3, I went straight through. Okay. And then I had my y-intercept up somewhere at 0,63. Okay. So that's the game we're playing. Let's try the next one. So this time I gave you a leading coefficient and the zeros. Now remember, if I give you the zeros, that directly relates to the factors, if you're thinking about this in factored form, okay? So I'm gonna actually write this with you for a sec. Let's just talk about those zeros. If I have an x minus 1, that's going to be x minus, sorry, if I have an x, I was thinking about the answer in my head, sorry about that. If I have a 0 at 1, the factor will be x minus 1, right? So that's going to be x minus 1, okay? I'm going to skip that -0.5 per sec. Let's go over to 6. The factor there would be x minus 6. I think you agree with that guy, okay? Now I want to talk about that -0.5. I want you to think about that as a fraction, and I want you to change your factor to be an integral factor, which means we don't want fractions as part of our factors. We want all of our coefficients in our factors to be numbers, okay? And so I'm just going to pause that one there, and let's just think about it this way. If I said x equals -1/2, okay? Well, let's get rid of the fraction by multiplying both sides by x. So we could say 2x equals -1. And then that would be 2x plus 1 equals 0. So, whoops, that's going to be my factor is 2x plus 1 equals 0. Okay, so if I did that, I'm now looking at y equals x minus 1. I've got that 2x plus 1, and I've got the x minus 6. Okay, now, here's the next thing I want you to look at. Your leading coefficient just got taken care of. Okay, and this is an important thing to think about, because remember, your leading coefficient is assuming that everything's been multiplied out. So if I multiply this out, I get x times 2x times x squared. My leading coefficient right now will be 2x cubed. Ooh, that was really messy, but 2x cubed. So I've already taken care of that leading coefficient of 2. Okay, so I don't need to add an a value here. I guess is what I'm suggesting, is what I want you to follow with. You don't just throw in a 2 in the front because you see that leading coefficient. You have to think about, is it already represented in the factors, or how much of it is represented in the factors, so that we can go and add in only what we need to make this happen. Okay, all right, so if that's what I'm looking at, The equation, so the degree will be 3, and the y-intercept, so I'll have -1 times 1 times -6. So the y-intercept will be at 0, 6. Okay? So go ahead and try and draw that. And this is what we should be looking at. Okay? So I had a 0 at -1/2 that I went straight through. I knew that this was degree 3, so it's going to behave like a line. I knew I needed to end up ending up. And because I was behaving like a line, that means I had to come in going up. So I knew I had to come in going up. I hit the 1/2. I come up to my y-intercept at 0, 6. Then I'm going to have to change direction and get down to hit my 0 of 1, which I'm going straight through because it has a multiplicity of 1. You have to assume a multiplicity of 1 if you're not told anything else, okay? And then I turn the corner so that I can get to my 0 of 6. And I have multiplicity of 1 there again, so I go straight through, okay? All right, so now this time I've given you the sketch of the graph, and I've given you the leading coefficient. Okay, so the leading coefficient is -2, which makes sense because I'm ending down. You need to come up with the equation. So if you think about this, let's just start writing the equation together. I'll do it up here with you. So I'm going to go y equals. I know that I have a factor of x plus 5 there. Okay, but I also know that that's squared. Okay, sorry, I don't have a math program in my video program, so that just means squared there. So I know I have to have x plus 5 squared, and then I also know I need x minus 3 as a factor, and that's going to have a multiplicity of 1. Okay, now I take a look at that and say, okay, that never took into account my leading coefficient, so now I'm going to need to have a leading coefficient of -2 there. Okay, because both x's didn't have a coefficient on them. Does that make sense? Okay, so the degree of this is going to be degree 3. And that matches the picture, right? Because I have 2 turning points. So all of this should match each other. All of this should feel comfortable as you're coming to these conclusions. The zeros will be at -5 and at 3. And then my y-intercept, I'm going to plug 0 in for x. So this, now be careful. You have to remember to square that. That's 5 squared, which is 25. So I got -2 times 25. So that will be -50. And then times -3. So that'll be 150. Okay. Remember, you weren't given any scale here, so don't get caught into thinking, wow, that should go up way more. You don't know. This could be like, this could be 200 right up here, right? And your scale could go accordingly that way. Okay. So I believe we got, oops, I believe we got all of that information there. Okay. Okay, now try this guy. So the degree is the sum of the multiplicities. So I've got 3 plus 2 plus 1, so it's degree 6. Leading coefficient, you got to be super careful with this guy. Leading coefficient will be 6 times 7 because there's a number there as well. And think about that. If that particular factor had been squared, then it would have to have been 6 times 49, right? You'd have to think through any exponent that you have on these factors. So for this guy, though, it's just 6 times 7. So the leading coefficient would be 42, which is positive, which means I'm going to end up. I said it was degree 6, so this should look kind of like a parabola does with a bunch of funky stuff happening in the middle. My zeros are at -4, and at -4 I will inflect. At 2, I will have a point of tangency, or I'll touch and change direction. And at 3/7 is that last guy, I'll go straight through. Okay. The y-intercept, if I just go underneath here, will be 6 times 4, 64, because it's 4 cubed. Everybody see where I'm getting that? Okay, if I plug 0 in for x, I'll have 4 cubed there. So that's 64 times 4, -2 squared, and then times -3. Okay. So 6 times 64 times -12 is -4,608. Okay, so 0, -4,608. So then try and draw the sketch of that and see what you can come up with. Remember, at -4, I need to inflect. At 2, I need to change direction. And at 3/7, I need to go straight through. I have a super, super negative y-intercept. And your sketch should look like this. Okay, so at -4, I inflected. Then I have my super negative y-intercept. At 3/7, I went straight through. At 2, I inflected. Overall, this behaves like a parabola. It's opening up overall. I have an absolute bottom to it. I have an absolute minimum. So everything's good to go. Okay. Okay, and then this guy with just letters, well, what can we do? We know that the degree is going to be degree 3. We know the leading coefficient is -a. I'll have a 0 at b and at -c, because this should have said x minus -c. Okay, so, and then I'll have a y-intercept. Well, I'll plug, well, let's talk about the zeros for a sec, sorry. The at b, I have to change direction because I have a point of tangency. And at -c, I'd have to go straight through. Okay. Then my y-intercepts, I'm just plugging in 0 for x, so I'd get -a times b squared times c. So that would be -ab squared c. I knew that my b, just think back to your transformations unit for a sec, if that helps. If I said x minus b, I know that I'm on the right of the y-axis. So that's where I have to have the x-intercept that changes direction. And then if I said x plus c, I know I'm on the left of the y-axis, and that guy could just go straight through. I knew I had a negative leading coefficient, so I knew I had to end going down. And I knew I had to behave sort of like a line. So if I end going down, I have to come in going down. And so that would fit the description of everything that we had there. Okay, so now what we want to do is come up with an equation for this line. Now, anytime we go to write an equation of a polynomial, we write it in factored form, and essentially we just list all our factors multiplied by each other with an a value. Okay, there's always an a value in the front, and then we find a friendly point, plug it in for x and y, and then we'll solve for the a value. Okay, so when I look at this guy here, I see that I'm going to have a root at x equals -2, which will be a factor of x plus 2. I see a root at x equals 1, which will be a factor of x minus 1. Then I also need to think about my multiplicities. At -2, how is that graph behaving? Well, I am inflecting there. That's a point of inflection. So that has to be a multiplicity of 3. Okay. At 1, how is the graph behaving? Well, I'm going straight through. So that has to be a multiplicity of 1. So when I go to list this in factored form, I have x plus 2 with a multiplicity of 3, and then I have my x minus 1 with a multiplicity of 1. Now, I need to find a friendly point. Well, I was given a friendly point. If you were given a friendly point in the question, make sure that is the point you use. So I'm going to plug 3 in for x and 50 in for y. Here I've got 3 plus 2 is 5, 5 cubed is 125, 3 minus 1 is 2. So that's going to give me 50 equals 250a. Divide both sides by 250. Oh, sorry, my animation was off there. Divide both sides by 250, and we get a equals 1/5. So my full equation, remember, a is not the answer. We just needed to find a to get the equation. The full equation is 1/5 x plus 2 cubed times x minus 1. Maybe pause me for this guy. Okay, so I see a factor, or I see an x-intercept. Let's start there. X-intercept at -2, so that's going to be x plus 2. That changes direction, so that'll be x plus 2 all squared. I see one at 1, so that'll be x minus 1, and that goes straight through. So that will just have an exponent of 1. And then I see another one at 2, so that'll be x minus 2. At that point, I will inflect. So I would have a degree 3 there. Okay, so I've set myself up with my a value and my factored forms. I'm going to plug in my friendly number. My friendly number this time around is 3, -6, so 3 in for x, -10. Sorry, I said -6. I have no idea where -6 came from. My friendly comment is my friendly point is 3 comma neg 10. So 3 goes in for x, neg 10 goes in for y. Okay, so now I got to clean this up. 3 plus 2 is 5, 5 squared 25, 3 minus 1 is 2, 3 minus 2 is 1, and 1 cubed is 1. So I end up with 50 on the right side. When I divide both sides by 50, I get negative 1 over 5. That should say negative there. That's a typo in the note, okay? So just add a little boop, negative there. And that should make sense, right? A should be negative because I'm opening down here. I'm ending down, and so the leading coefficient should be negative. Remember, we've talked about the fact that there's so many check and balances in how you do this work. So you should always feel like, no, this makes sense. This answer fits with what's happening. Okay, and so then the equation itself, we just throw that a value in. And again, I'm missing that negative, so we'll put a negative right there. Okay, so it's negative 1/5, x plus 2 all squared, x minus 1, and x minus 2 cubed. Okay, good stuff. All right, so sketch the following polynomial without the aid of your graphing calculator. Well, we need to start getting some of these points. We need to get the y-intercept, we need to get the x-intercepts. The way we get the x-intercepts is we factor it. Then we also, once it's factored, we can look at the multiplicity and decide the behavior of the graph along the x-intercepts, okay? So the y-intercept here, let's start there. If I plug 0 in for x, I'm going to get out 0. So the y-intercept would be 0, 0. The x-intercepts, well, I want to factor this. So the first thing I see is I can factor out an x. So I'm setting y to be 0. I'll factor out the x, and then I'm left with this trinomial. Do you know two numbers that multiply together to give you negative 30 and add together to give you negative 1? Yes, you do. They're negative 6 and 5. Okay, so I'm going through the process of decomposition here. If you factor another way, that's totally fine. You should end up with x times 2x plus 5 times x minus 3. Okay, so that tells me I have 3 x-intercepts, one at 0, one at negative 5 over 2, and one at 3. They all have a multiplicity of 1, so they will all go straight through. I know I have a leading coefficient that's positive, so I need to end up. I know my degree is 3, so I need to behave sort of like a line with stuff happening in the middle, so that means I'm going to come in going up and leave going up. Okay, so degree 3 and 3 x-intercepts, so each will have to go through. A is positive, so I end up. I have an odd degree, so as x approaches negative infinity, y must be going down. Now, that's the same thing I said. I don't want any confusion there, right? I said coming in, I would be going up, and going out, I would be going up. That says as x approaches negative infinity. So that's actually reading right to left now instead of left to right, okay? Either way, I'm shooting down this way, and I'm shooting up this way, okay? Okay, so there is only one way to connect those dots, and it would look something like this. Now, again, I know I've talked about this, but you don't have any knowledge of how high this would go without a graphing calculator and how low this one would go without a graphing calculator, and that's totally okay, okay? We're looking for the general shape when we get you to do this. Okay, so let's try this guy. So again, this one's a little messier for sure, but the process is the same. My y-intercept I can get by my constant term, or I can get by plugging 0 in for x. My y-intercept here would be 8, 0, 8. My x-intercept, I need to start going through the process of factoring. Okay, so first thing I did was I set y equal to 0. Then I took out the negative 4. Now I'm going to look for a factor. So I'm going to test p of 1, p of negative 1, p of 2, p of negative 2. The fact that the constant term now only goes up to negative 2, one of those should give it to you, right? 1, negative 1, 2, or negative 2. Those are the only things you can try. We end up that p of 2 works. P of 2 is 0, therefore x minus 2 is a factor. Okay, I need to see that statement. Now that we have that statement, what do we do with it? Well, we go into dividing it. So either we use long division or synthetic division, doesn't matter. I set up synthetic division. Okay, I wrote down my coefficients. Now remember, I'm using this guy here because I've already factored out the 4, the -4. So I'm using this to synthetically divide. You're always using what you're currently working with, not the original. So 1, 1, -3, -5, -2. I have every degree represented, and it's going in order from highest degree to lowest degree. Okay, so I do my synthetic division, and I end up with, so far, in factored form, this would say 0 equals -4. I'd have x minus 2, and then I'd have x cubed plus 3x squared plus 3x plus 1. Okay, so now I am off to factor this little bit. Okay, so I need to find a factor because that's still degree 3. I'm not ready to go and do decomposition or however you factor trinomials, because this is not a trinomial yet. This is not a degree 2, it's a degree 3. So I have to go through this process one more time. So plug in p of 1, plug in p of -1, plug in p of 2, plug in p of -2, find a factor. So -1 worked this time. It would have worked last time too. I didn't necessarily go in the right order, but p of -1 is 0. X plus 1 is a factor then. So again, I have to divide it out, either long division or synthetic division, whichever you like. So I've got -1. Again, remember I'm working with these coefficients now. So 1, 3, 3, 1. I do my synthetic division and I get x squared plus 2x plus 1 out of there. So now my intermediate step, I always want to see this intermediate step because that's part of the factoring process, right? I don't want to see you just glue factors together at the end. Every time you've done synthetic division, I want to know that you know where you are right now. Synthetic division breaks things into 2 factors. So this particular synthetic division broke this x cubed polynomial into x plus 1 times x squared plus 2x plus 1, okay? So now I'm looking at the x squared plus 2x plus 1, and I have to continue to factor that. So I'm looking for 2 numbers that multiply together to give me 1, add together to give me 2. And that would be x plus 1 and x plus 1. So, okay, so I see that I have a multiplicity of 3 on the x plus 1, so that will inflect. I see that I have multiplicity of 1 on the x minus 2, so that'll go straight through. So at x equals -1, I will have a point of inflection. At x equals 2, I will have a, I'll just go straight through. I know I have the point, the y-intercept, which is 0, 8. I know this is a degree 4, which means I'm going to behave sort of like a parabola. And I know I have a negative leading coefficient. So if I end down on that side, I'm going to end down on this side as well, right? And then I'll, whatever is happening in the middle, but both of them will end down because of this general kind of behavior of a parabola, okay? All right, so I'm taking stock of everything I've got. We talked about the fact that A is negative. We talked about the fact that it was an even degree, and I just plot the points. Okay, so that should be the general shape that you end up with. Okay, so just to summarize, your leading coefficients, if your leading coefficient is positive, the graph will end up, and if the leading coefficient is negative, the graph will end down. We've talked about multiplicities, so that is the exponent on a factor. If the exponent is 1, the graph will go straight through. If the exponent is 2, it'll change direction. You've also heard me call that a point of tangency, or it touches. Okay, and then and that would work for any even multiplicity as well. So if it was 8 or 10, the same thing would happen. And then for 3 or any other odd one higher than 3, it would cause a point of inflection. Okay. Even functions have a positive leading coefficient, or even functions that have a positive leading coefficient would sort of open up altogether. So they kind of behave like a parabola. So both ends are opening up, and a negative leading coefficient, both ends would be opening down. Okay. So I said here, as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity. well, sorry, y approaches infinity. They both go up. The negative leading coefficient would be as x approaches infinity, y approaches negative infinity, it's going down. And if I go the other way, as x approaches negative infinity, y is also going down, so to approach negative infinity. For odd functions, they behave sort of like a line. So a positive leading coefficient, as x approaches infinity, y is going up as well, so it will approach infinity. And as x approaches negative infinity, y will be approaching negative infinity. And then the opposite for negative leading coefficients, as x approaches infinity, y is going down, so it'll be approaching negative infinity. And as x approaches negative infinity, y is approaching infinity. I know that all those infinities can feel a little overwhelming. I want you to kind of walk through that yourself and just kind of map it out. But essentially, that's why I keep saying even functions kind of behave like a parabola. You just want to think about them as a parabola that is going to either open down or open up. And then there's just funky stuff happening in the middle. Okay, and then odd functions behave like a line in the sense that they come in and go out if you're reading left to right in the same direction. Okay. All right, so that's where we'll stop for today. You have your homework there that you can get practicing on, and if you have any questions, make sure you come and see me. Okay. Have a great day, guys, and we'll see you next time for polynomial applications.